All right, this is a trick you need to know how to do. I see that we have sine beta, so it's probably a good idea to turn everything into sine beta. In fact, that's the only thing I can do. There's nothing else you can do to this problem, is turn your cosecants into 1 over sines. And now, like I've said almost every single day, you need to get rid of fractions. You can't have fractions in the numerator. You can't have fractions in the denominator. And what's going to get rid of both of them is you're going to multiply the top by sine of beta over sine of beta. That's multiplying by 1. That's getting rid of fractions. Now when I distribute this, it goes to everything in the numerator, goes to everything in the denominator. Sine beta over sine beta is just 1. This is just going to be sine beta over sine beta, which is 1 minus sine squared beta. Well, 1 minus sine squared beta is just 1 over cosine squared beta, which is just going to equal secant squared beta, which is d. It was realistically the only way you could go. There's no alternative method to it. There's no way to break apart the fraction. There's no way to push fractions together. In fact, there's no way to move anything at all. In those cases, you have to rewrite cosecant as 1 over sine, especially because there's sine already in there. All right, so the correct answer was D, secant squared beta. Got to know how to do this, guys. Test is on Tuesday. I would consider this one to be one of the easier ones because there's only one way to do it. There's no pushing fractions together. There's no pulling anything apart. It really is just replacing cosecant with 1 over sine. All right, questions from the homework? Yeah. The last one. So this isn't one I would really put on the test unless I was putting it as extra credit. Because this one, there's so many different roads you can take. Like the bell work, there's one way you could take it. You have to rewrite the cosecants and you need to get rid of them. That is the only method you could even do. Anything else you did probably wouldn't have made any sense to do it. But in this case, there's multiple roads you could go down and lots of roads that lead nowhere. The first thing you need to do is, like I said, anytime you see an addition in your angles, you have to write it out fully. So cosine of alpha plus beta is cosine alpha, cosine beta, minus sine alpha, sine beta. Well, sine of alpha minus beta, you can expand that into sine alpha, cosine beta, minus sine alpha, cosine beta. And like I said, I'll say this a million times till I'm blue in the face. Anytime you see this, you have to expand it. That was the starting point of every single one of these problems, was to expand those. You should have at least been able to do that. None of these problems should have been ones that you just got stuck on in the first step, because the first step on every one of these except for the 2 on the top of this page were the exact same. Turn that addition sum into these. So you take that as your numerator, and this is your denominator. Now here there's tons of different ways you can go with it, and none of them are going to work except for this one method. So this is a really tough problem. And what you needed to recognize was the fact that on my right-hand side, I need something minus something over something minus something. Well, that's what I have. On the left-hand side, I have something minus something over something minus something. Well, what you needed to recognize is this cosine. Yeah, maybe I should pick a different color or erase this. What you needed to recognize was this cosine, alpha beta, is in the place of that 1. These share the exact same space, just on opposite sides. One's on the left-hand side, one's on the right-hand side. So you would ask yourself, how can you turn this into 1? Well, the only way to turn this into 1 is to multiply by its reciprocal. If you have 2 and you multiply it by 1 over 2, it turns to 1. So you need to multiply this one purple thing by 1 over cosine alpha cosine beta. The problem is you can't just multiply one element by whatever you want. You have to keep a balanced equation. So knowing I needed to multiply this first term by 1 over cosine alpha cosine beta means I need to multiply the entire numerator by that, which is what I did here. But in order to multiply the entire numerator by a number, you have to multiply the denominator by that same number, just like in bell work where I do sine of b over sine of b, so I was really multiplying by 1. Well, if you did this, multiplying the top and bottom, you actually have your answer. This is your one step. So when you distribute this, all across our numerator, and then all the way across our denominator, you would get what I have here. Everything's over cosine alpha, cosine beta. Well, if we look at that first part right here, that has to equal 1. It's the same thing on top of the same thing. Our next thing is sine alpha over cosine alpha and sine beta over sine beta, which turns into tangent alpha, tangent beta, and the same thing's going to happen in the denominator. So it's a really tough problem because there's multiple rows to go down, and this is the only one that works. Okay? Other questions on this one? Okay, other questions? 89. So 89, you had to recognize what I've been saying over and over and over again. That's not 89. That's 87. It says specifically, I have tangent s plus t. I have tangent s minus t. Anytime you have those, it should be a knee-jerk reaction that you write them as their expanded form. That's how you start every one of these problems. I can't say it any more than that. That if you see a problem that has two angles being added, you have to expand it first and foremost. That's how every one of these problems worked. So I'd expand that tangent of s plus t into a tangent s plus tangent t over 1 minus tangent s tangent t. But that also means that you need to know these formulas. And then tangent s minus t would be tangent s minus tangent t all over 1 plus tangent s tangent t. Well, if we look at the numerator and the denominator, these are just difference of squares. That was the thing I said you have to know how to do. On the top, I have tangent s plus tangent t. On the top over here, I have tangent s minus tangent t, which is a plus b, a minus b. So we just have to have a squared. Once again, let me put notes by that, because this is going to shortcut your life so much. That's my a, that's my b, that's a plus b. This is my a minus b. So that's just going to equal a squared, which is my tangent squared s, minus my tangent squared t. You could have also distributed, all right? So if you don't recognize the a plus b, a minus b, you can also just do your FOIL or whatever you have to distribute the top. Then you're going to do the same thing on the bottom. The same thing on the bottom happens. It is a minus b times a plus b. So it's just going to be a squared, which is 1 squared, minus b squared, which turns into tangent squared, and that's exactly what we had. So this whole problem, I told you how to do it. I told you the first thing you do is you do this, where you expand it. You just had to multiply. You just had to know how to multiply something plus something times something minus something. That's the only skill you had to have on this one, and then you had your answer. It just looks harder with tangents. Yeah? You would never have to cross multiply because the only time you cross multiply would be if you had something like 1 over 2 equals x over 3. That is the only time you cross multiply. And the problem with that is we're not allowed to do stuff to both sides. So you can actually never cross multiply when you're doing those identities. Does that make sense? Okay, good. So don't even just forget you even know how to cross multiply when you get to these. Isabel, does that make sense?
Yeah.
Okay. Other questions? Yeah, Jeff.
83.
So 83 and 84 kind of were in the same vein. But the good thing is, if you just follow my steps that once you see something, you do something, and then you just multiply, you almost get to the end. So on 83, I'm going to recognize right off the bat that I need to rewrite sine of alpha plus beta, which is right here. Then I'm going to rewrite sine alpha minus beta, which is right here. Once again, this turns into either I know the formula or I don't know the formula. Then you just need to distribute. This is, a binomial times a binomial. You can either just distribute everything, or recognize that it really is, now let's do it in purple, this is A plus B times A minus B, since everything is the exact same. My A is the same thing as my A over here. My B is the same thing over here. So I could have just said A squared plus B squared, which is why I got this. I just squared everything in my A term. So I have sine squared alpha, cosine squared beta, minus cosine squared alpha, sine squared beta. You would have came out the same thing if you just distributed it. Now you have to look at your right-hand side. Your right-hand side has nothing but signs in it. It has, let me erase a bunch of work that I just did here. So what I'm looking at is I see that we have sine squared alpha in our answer key. Well, if I skip to this second step, I have sine squared alpha right there. Then it says that I need to have sine squared beta. I'm going to recognize that I have sine squared beta right here. The only thing I need to get rid of are the two cosines. So you look at what you have and what you need to get rid of in these problems. Well, to get rid of cosine squared beta, I'm just going to turn it into sine squared. So I take that cosine squared beta and I rewrite it as 1 minus sine squared. And that comes from our sine squared plus cosine squared equals 1. You can then write cosine squared equals 1 minus sine squared. Does that make sense, Jeff? Just want to make sure I'm not. Okay. And then we do the same thing for the other cosine that I don't want. I rewrite that in terms of sine. And then it comes down to just distributing. So I'll have sine squared alpha. And then we have sine squared times sine squared, which would be sine squared alpha, sine squared beta. You distribute this negative sign and that sine squared beta. If you do everything correct, you're going to end up with just sine squared minus sine squared beta. Does that all kind of make sense?
Yeah, I just didn't use the sine equation. I just distributed sine A and B.
Yeah, no, I saw what you did, but it's not correct. You can't do that. Because you never turn you didn't really turn the cosines, you just kind of canceled stuff out somehow. But the only way to cancel it out is by changing it to sine squared. It's the only method that works here. Other questions? But do you see how it kind of matches 84? Because it looked like you did 84 correctly.
Yeah, but that was different because it had cosine and sine on the other side, not just sine and sine.
Correct. But it's the same method. You just have to locate what you need and what you need to change. So on this one, I kept both my signs. On that one, I'm going to keep a cosine and a sine and change the other values. Does that make sense?
Yeah.
Okay. Other questions? Okay. Then what you have in front of you is just